So, greeting students. So, in today's lecture, we will be dealing with the induction machines. Okay. So, first we will be have to know about what is an induction machine. So, this induction machine. So, generally, it is you can operate the induction machine in both your. It's possible to operate in both your what you can say. Either you can operate it as a motor or you can operate it as your generator. So here we'll be seeing about the construction of your induction machine. So this induction machine is a AC machine. It is this machine will be working on your AC quantity. So this works on your AC quantity. So here we will be in this lecture we will be dealing with the construction of your induction machine. So first you have to know about the brief intro. So the three-phase induction machines are the most commonly used. So rather than your single phase, mainly in the industry point of view, I am talking. So why it is used as a common machine in your industries means due to the advantage of simple design, rugged structure, low price, and then the maintenance is also easy in case of your induction machine. Also, the induction machine will be you can operate your induction machine for a wide range of power rating. That is, if your induction machine is rated for a 10 megawatt in the sense, okay, so it can operate from 0 to 10 megawatt. So more effectively, it can operate in this range. So it can operate in a very wide range of power rating. So it runs essentially as a constant speed motor. So similar to your DC shunt motor, it is also constant speed motor. So if you're taking a AC machine means the constant speed motor is your induction machine. Okay, its speed depends on the frequency of the power system or the power source. Okay, that is here what they're saying is the induction motor will be will be it is an AC motor, right? So it will be controlled by a AC source. So it will be controlled by a AC source, and this speed of the motor N. Okay, the speed of the motor N will be based upon your frequency of this source. Okay, so at what frequency this operates, based upon that frequency, this speed also varies. Hence, in order to control the speed of the motor, you must need a variable frequency power electronic drives. Okay, so those are the devices, power electronic devices, which have to be connecting with your induction motor to control the speed parameter. Okay, so this is a brief intro about your induction motor. So now we will be moving to your construction part. So the construction will be having two main parts. Okay, the construction will be having two main parts, similar to the other kind of the motors. So all the electrical machines will be having either it can be a generator or the motor. It will be having a stator, which is your stationary part. Which is your stationary part. Okay, so this outermost part is nothing but your stator. Okay, so this is the structure of the stator of your induction machine. So this stator will be stationary. This stator will be stationary, while the rotor is the rotating part. And the rotor is your rotating part of the motor. So the stator will be made up of what material? That you have to see. The stator will be made up of steel frame. So why we are making use of steel frame means in order to have your flux linkage, similar to your transformer. So this also has to will be depending upon your flux linkages. So if you want to have a very increased flux linkage means you must have a steel frame of low reluctance. Okay, steel frame of low reluctance. So this stator supports a hollow cylindrical core, so which is nothing but a rotor. Okay, the core constructed from the stacked laminations. Whenever the laminations are coming out, what is the main purposes of the lamination means to eliminate your to eliminate your eddy current losses. So that's the main perspective of your uh, laminations. Okay, so these data will be also similar to that of your transformer stacking. So in a transformer, each and every stampings will be stacked on one above the other. Similar to that, over here also, your stator part will be stacked one above the other. So construction wise, stator is over. Next, moving on to the rotor. Rotor is nothing but the revolving part. Okay, it composed of punched laminations. This also will be having laminations. Again, the purpose is to limit your eddy currents. To limit your eddy currents. So here also it will be stacked, but the stacking will be a series of the rotor slots. So the rotor will be again of two types. It is of two types, starting with your wound rotor and another one is your squirrel cage rotor. So in your wound rotor, so we are talking about three phase, right? So in the three phase, the wound rotor will be having windings. Okay, that is in your rotor itself, there will be windings. Whereas in case of a squirrel cage, you won't be having any windings. Instead, you'll be having aluminum bus bars. Okay, so here it is, aluminum bus bars you'll be having. I'll be showing it. So construction types, as I said, squirrel cage and then wound rotor. So squirrel cage will be having conductor bars laid into the slots. Okay, wound rotor complete set of three phase windings. Okay, wound rotor means windings will be there. Whereas in case of squirrel cage, we having only what you can say bars. So here you can see this is your squirrel cage. Okay, this is your squirrel cage. So what you have to see is that this is the entire thing is a rotor. This entire thing is a rotor. Okay, this entire thing is a rotor, followed by this entire thing is a rotor. Okay, this entire thing is a rotor. So here there is some holes, right? So within this holes there will be windings. Okay, so here there will be windings, whereas here you can see it has some slotted bars, which will be calling as bus bars. Okay, but here if you are seeing means it will be of windings. Okay, so that is the main difference between your squirrel cage rotor and your wound rotor. Okay, so here another one main part is here we will be having a slip ring. Okay, so this slip ring is an important parameter in the control of your speed, in the control of your speed parameter, that is n. So I think the control of your speed parameter. Okay, so this is the main thing, the difference between your squirrel cage and your wound rotor. Okay, so this is a cross-sectional view of your uh, induction motor. So here what happens is that the view is just cut out. Okay, just cut out. So here you can see your slip rings. So these are the slip rings. Okay, that is they will be connected to your rotor part. Okay, so this is what with respect to your construction of your induction motor. So thank you.